We are given two cylinders loaded as shown, and they are connected by a rigid rod parallel to this smooth cylindrical surface. And we are tasked to compute the value of angle A and angle B. And to do so, we first construct our free body diagram. So for this figure, the 400 Newton force will induce a reaction that is normal to the surface of the cylinder. In the same way, the 300 Newton force will also induce a reaction that is normal to the cylinder. And because these reactions here are normal, they are concurrent at this point here, at the center of cylinder. So since we are only interested in solving for the angle A and B, we're going to take moment at point O so that these two forces here will not be taken into consideration in our equation. So taking summation moment, point O equal to 0, taken counterclockwise to be positive, we have the 400 kilonewton force times the moment arm distance that is equal to R cosine of E. Minus, because made this clockwise, 300 times the moment arm distance equal to R cosine of B. It's equal to 0. Now dividing both sides by R, we have 400 cosine A minus 300 cosine B equal to 0. And dividing both sides by 400, we have cosine A minus 3/4 of cosine B. So we have cosine A is equal to 3/4 of cosine B, and that serves as our first equation. Now for the second equation, we make use of the geometry of the figure. Now notice that angle A, 90-degree angle, and angle B forms a straight line. So A plus 90 plus B must be equal to 180 degree. So minus both sides by 90, this is A plus B is equal to 90 degree. And that serves as our second equation. Okay, so now that we have two equations with two unknowns, we can solve for angle A and B by manipulating the second equation. We have A is equal to 90 minus B. And we plug in this value into the first equation so that we can represent the first equation in terms of the singular variable B. So we have cosine 90 minus B is equal to 3/4 of cosine B. And using the co-function identity, cosine 90 minus B is basically equal to sine of B. So this is equal to 3/4 cosine B. Dividing both sides by cosine B, we have sine B divided by cosine B is equal to 3/4. And sine B over cosine B, that is just equal to tangent of B. So to solve for B, we take the arctangent function. So we get B is equal to arctan 3/4. So B is equal to 36.87 degrees. And to solve for A, we make use of this equation. This is A is equal to 90 minus B. So A is equal to 53.13 degrees. So A is equal to 53.13 degrees and B is equal to 36.87. And that is our final answer.